Welcome students to the course of Programming Fundamentals with Python. This is week number 11, and in this week we will talk about nested list and tuples in Python. Here is a brief roadmap outline for today's presentation. I will talk with objective what is expected to learn from this week. After that, I will discuss the two-dimensional list, their syntax, examples, and how we use them in our programming. The second topic for today is tuples, which is another type that we can use in Python programming. We will see similarities and differences between tuples and list. After that, we will shed some light on how we can create and use tuple in Python, how we actually access the elements of a tuple, how to use loops inside tuples, and using of index to access the elements of the tuple. So let us start with a brief objectives, discussion on objectives. At the end of this week, you will be able to learn about two-dimensional list. We have already covered the single list or normal list in week number 10. In this week, we will study about the two-dimensional list. After that, the second topic is about tuples, so you will learn about tuples as well. Both these topics will enable you to write programs that will demonstrate the use of two-dimensional list and tuples. Now the first question is that what is actually a two-dimensional list? The two-dimensional list are also known as nested list or list of list. As we are already familiar with the word nested, we have seen it in the nested for loops, nested if else statement. In a similar way, a nested list is like a list inside another list. If you placed a list inside another list, then it is referred as a two-dimensional list. A two-dimensional list, so we can say that it is a list that has other list as its element. Normally a one-dimensional list has an element like integer, floating point, boolean, or string, while a two-dimensional list will have another list in its element, and that sublist will contain the elements. So the element of a list can be virtually anything. It could be integer type, it could be float type, string type, or boolean type. To see the general syntax of a two-dimensional list, let us consider this example. First, you have to mention the name of a two-dimensional list. It could be any valid variable name, which is followed by the equal sign, which means assignment operator here. And from here, you can see that we are using two opening brackets, square brackets. One the outer and the second one is the inner. The outer one represent the list and the inner one represent the element. So you can see the element of this list is not a usual element. It is actually a list of element, means another sub list. Okay. In this case, we have a nested list which contain three sub list, or you can say it has three elements and each element is also a sub list. They are separated with the help of commas. Here in this syntax, we have write the three sublist in 3 lines. You can also place these lines in a single line like this. Okay, so that is possible. Python will accept this indentation because it is the syntax of a nested list. After that, let us see some examples which will demonstrate the concept of a two-dimensional list. As we just saw in the syntax, first you have to mention the name of the list. In this case, the name of our list is students. And then you have to initiate the opening brackets, square brackets. In this case, we have 3 sublist. Sublist number 1 contain 2 elements, sublist number 2 contain 2 elements, and also the 3 sublist contain 2 elements. Here the elements are all of string type. It could be of any type, right? Integer, floating, character, boolean, etc. That is possible. Okay, now these are different statements by using which we can actually display the elements stored in this list. Let us see the first print statement. Print students. It will display the whole list, the two-dimensional list. So the output is all these things. Once you execute this statement, it will display the whole list, all the elements, all the sublists which are contained in this two-dimensional list. Second one is print student 0. Here we are providing index, and it means index of the first sublist. This sublist has an index of 0. The second sublist has index of 1, and the third sublist has index of 2. Once you write print students 0, it will display Joy and Kim, the first sublist element. And in a similar way, this will display the contents of the second sublist, and the third line will actually print the contents of the third sublist. Okay, so line it will actually, you can say that it will actually display the entire student list, while this print statement will display the student the first sublist students, and then the second sublist student, and the third sublist students. To think about a two-dimensional list, you may consider it like a table having rows and columns. The above example can be represented in a two-dimensional list in this way. Two-dimensional table. Each of the row index is started from 0, while each of the column index is also started from 0. So this figure shows a two-dimensional list of the above example. Notice that the rows and columns are numbered from 0, and the final number is 2 in the case of rows and 1 in case of column. There is a total of 6 elements in this list. From here we can say that it is a useful way to work with sets of data. Now let's suppose you have a teacher, and the teacher is teaching to 3 different students, 3 different subjects. Okay, we have a teacher who is teaching 3 different subjects to 3 different students. And the teacher is interested to represent their marks, represent the marks of each and every student in each and every subject. For that purpose, the teacher can actually use a two-dimensional list having 3 rows and 3 columns. The 3 rows will represent 3 students, and the 3 columns will represent the three subjects, and each column will contain the marks of a respective student in that respective subject. Okay, so this is a better way, a better approach to represent such type of data. And here is how you can actually refer to the individual marks, score, result of the students when it is represented in a two-dimensional list. Suppose the name of this two-dimensional list is scores. Okay, this first row is about student number 1, second row is about student number 2, and the third row is about student number 3. Same is the case with the columns. This is for subject number 1, subject number 2, and subject number 3. If you want to access the score of the student number 1 in this particular subject, so you have to access this cell by referring to 2 indexes. The first index will refer to the row, and the second index will refer to the column. This is row 0, column 0, row 0, column 1, row 0, column 2. Row is constant, column is changing. If you consider this way, then column will be constant and row will be changing. Column will be constant and row will be changing. Here you can see that you can access actually the score of the first student by referring to the indexes like this. 0 represent student number 0 here, or row number 0, and these indexes represent the columns. And the columns, it represent the subject number 0, subject number 1, and subject number 2. In a similar way, if you want to access the individual scores of the second students, for that you have to follow this syntax. Student number 1, or the second student, is in row number 1. So the row again is constant, the columns are changing. Okay, so this will actually display the score of the first student in 3 different subjects, and same is the case for the third student. In summary, to access any element of a two-dimensional list, you will need two subscripts. The first subscript will represent the row, the second subscript will represent the column. Let us see an example. We have a continent which is known as Asia. Asia has different countries. Some of the countries are mentioned here. Again, it indicates the double starting square bracket represent that it is an example of a two-dimensional list. Again, the list is of string type. And in this two-dimensional list, we have 3 rows and 3 columns. 1, 2, 3. 3 rows, 1, 2, 3, and 3 columns. Now, let us see what each this statement will do. Print Asia 0. It will display the first sub list of this two-dimensional list. That is India, Japan, and Korea. The second will actually display a specific value. Go to row number 0 and column number 1. So this is row number 0 and this is column number 1. It will display Japan, this one particular element, because we are providing 2 indexes. The first index is for the row and the second index is for the column. And the third print statement will display the whole two-dimensional list, as we are not providing any index. So it will print the whole list. Example number 2. This will demonstrate the use of nested for loops to deal with two-dimensional list. Here we have created a two-dimensional list which has 3 rows and 4 columns. To represent it in a matrix form, in a table form, it is going to be like this. We have 4 columns and 3 rows, and the value of each element is 0. Similarly for others. And the indexes, this is actually 0, 0, because this is row 0, this is row number 1, and this is row number 2. This is column 0, this is column number 1, column number 2, sorry about my writing, and this is column number 3. If you want to refer to this element, you have to provide the index 0, 0. If you want to refer to this element, you have to provide the index 0, 1, and so on. I also have 2 variables with the name rows and column. They actually represent the total number of rows here and the total number of columns here. So they are 3 and 4. Now I need 2 loops, nested loop, to deal with nested list. Okay, the first loop has a variable r, and the second loop is dealing with a variable c. R will take value from rows, C will take values from columns. If you open this loop, that is going to be like for R, starting value is 0 and the last value is 2. Starting value is 0 and the last value is 3. So this loop will execute 3 times, while this loop will execute 4 times. This is outer loop, this is inner loop. For one value of the outer loop, we have to execute the inner loop completely. Okay, so the initial value of this nested for loop is row is 0 and column is 0. Okay, these are the 2 values. Then we are providing these values as an index to the list. You can see it from here. The value of R is 0, the value of C is 0, and values is name of this list. Go to 0, 0 location of this list and assign 10 there. This is 0, this is 0. come here and assign the value 10 to this location. Then after execution of this statement, go back to this inner loop, increment the value of c by 1. Now the new value of c is 1. Okay, come here, go to the list values and the index or subscript 0 and 1. This is 0 and this is 1. Come to this location and assign the value 10 there. Same is the cases for other two. After that, the condition in the inner loop will become false. Then we have to go back to the outer loop and increment the value of row by 1. The previous value of row was 0. The new value will be 1. And again, we have to execute the inner loop 4 times. The first value, the first index is 1, 0. Go there and assign 10. This is 1, this is 0. Come here and assign 10 to this location. Same is the case for the rest of the values. This program will assign 10 to all these locations, all the cells of this table. Okay, this program is a bit different, and the only difference is that now we are using something which is known as import random, which is a library which contains random numbers, random number generation. If you want to deal with random number generation, then you have to import this library, and this is same like same in the C++ or C language. We are using hash, include, conio, string, etc. The libraries, the header files. In Python, we also do have a large number of libraries available. Instead of assigning 10 to all these cells, why not to assign a random value to these cells? For example, 10, 20, 30, 40, 50, random values. For that, we have to import the library first, and then instead of writing 10 here, you can write this line of code here. Random integer, initial value, and 100 final value. What's going to happen here? It will actually assign a random value between 1 and 100 to each of these cells. The number will be generated automatically and it is random, and it must be between 1 and 100, and that value will be assigned to each and every cell of this two-dimensional list. So you can also use this line of code to provide a random number to the cells instead of a constant value. Let us see another example. This is simple as well. I have a list with the name my list. Again, it is a two-dimensional list having 3 sub-lists here. And then I have rows and columns. Total number of rows is 3 because we have 3 here, and total number of columns is 4 because we have 4 columns here. After that, I'm using multiple for loops or nested for loop to deal with the two-dimensional list. What I'm doing here, I am providing the indexes ij. I index will come from here, j index will come from here. The value of row is 0, the initial value is 0, the initial value of column is also 0. So I will be replaced by 0, j will be replaced by 0. What I'm doing, I'm using indexes to access the element of this list. I'm using indexes, and I need 2 indexes to deal with the two-dimensional list to access the element of this list. So go to my list and go to location 0, 0 and print the value there. So this is 0, 0 location. It will print 1 on the screen. In the next iteration, the value of call will be incremented by 1, and then here the value of j will be 1. Now go to my list, go to the index 0, 1, go to the position 0, 1 and display the value there. This is 0, this is 1. It will display 2. In the next iteration, it will display 3, then 4, 5, 6, 7, 8 and so on. Okay. So the objective of this example is to let you know that you can use indexes not only to assign value to the list, but also to access and print the values of a two-dimensional list. Second topic for this lecture is tuples. Tuples along with list are the most used feature or used container type in Python. Remember, we also have some other types of container beside from list and tuples, and they are dictionary and sets. Like the list, a tuple is also a sequence, and it is very much similar to that of the list that we have covered. However, there are some differences, and the primary difference between a list and a tuple is that lists are mutable, tuples are immutable. What does it mean? It means that you can change the values of the list during the execution of the program, while the values of the tuples cannot be changed during the execution of the program. It means that once a tuple is created, it cannot be changed. That is the primary difference. But there are some other differences as well. Or you can say that if this is the only main difference, why we need tuple? You can use list instead of using tuples because that is much more powerful than tuple. The answer to this question is that tuple has good performance over list because the processing of a tuple is faster than the processing of a list. So they are actually a good choice when you are processing lots of data and the data will not be modified. In that scenario, you can actually use tuples instead of using the list. Another reason for the tuple is the safety. Because you are not allowed to change the contents of a tuple, you can store data in one and rest assured that it will not be modified accidentally or otherwise by any code in your program. And also there are certain operations in Python that require the use of tuple. So in summary, a tuple is an immutable ordered collection of objects. There is each element in tuple has a specific position, and we know that to refer to the position, we actually require the use of indexes, and that position also does not change over time. Indeed, it is not possible to add or remove elements from the tuple once it is created. And here is how we can actually create tuples. The syntax is very much similar to that of the syntax of a list. First, you have to write the name of the tuple, and then you have to write the elements of the tuple separated by commas. In case of a list, we use square brackets to represent the elements. In case of a tuple, we can actually use parentheses to enclose the elements of the tuple. One more thing, like the list, tuples can also be multi-dimensional, two-dimensional, or even three-dimensional. So this is a proper way of creating the tuple, and if you want to display the elements of the tuple, you can use the print function by providing the name of the tuple. What's happening inside the memory is like this. You have a box. Inside the box are the individual elements of the tuple, and each element can be accessed by using an index, and the starting index is always 0. Now if you want to access the elements of the tuple, here is a way. I have a tuple with the name my_tuple. It has 4 elements. If I want to access the first element, then first I need to write the name of the tuple and then provide the index inside the square bracket. This will refer to the first element of this tuple, and similar for the other indexes. It will print all these elements one by one. Okay, like list, tuple can hold different types. A tuple can contain all integers, it can contain all floating point values, it may contain all string type data or boolean type data. Even more, it can contain a mixture of data. For example, in this example, you can see that my tuple hold 4 elements. The type of first element is integer, the type of second is string, the type of third is float, and the type of the fourth is a boolean, that is true. You can use loops inside the tuples as well. In this example, I have a tuple with the name my_tuple, and it has 5 values. Okay, you see I have repeated the apple, so repetition is also possible in the elements of the tuple. If you want to display these elements by using a for loop, then the syntax is like this. This is the loop variable, control variable, n is the keyword, and my tuple is name of the tuple. It will take, this loop will take values from this tuple. So print x. What is the value of x? The initial value of x is apple. It will print apple, then it will display pear, then orange, then plum, and then apple. So you can use loops in a similar way as we have used them with list to deal the tuples. More about indexing. The first element is stored at 0 index location, we know it. The second is stored at first location, and the third one is stored at second location. This will refer to the first element, this will refer to the second element, and this will refer to the third element of the tuple having names. Uh, Last thing to remember about tuple is that it is not possible to add and remove elements from a tuple. You see, we have restrictions on the tuple. In list, you can add an element to the end of the list or any specified location. In a similar way, you can remove elements from the list, but you cannot do with the tuple because they are immutable, they cannot be changed. It should be particularly noted that none of the functions or methods presented with the list actually change the original tuple. If you want some methods to be applied to the tuples, you can apply them, but they will not change the tuple. They will actually return a subset of the original tuple. Or you can say it will return an instance of the class. Or in other words, tuple has no effect on the original tuple. Uh, However, as I just mentioned, the tuple does not support many methods. For example, append method, which is available in the list, remove, which is available in the list, insert, reverse, sort, etc. They are not possible with the tuples. And finally, an important consideration to remember about the tuple is that if you want to create a tuple with just a single element, you must have to write a comma after that element. If you forget to put the comma at the end of the element, just like this, then it will not be considered as a tuple. Rather, it will be treated as an integer having a value 1. But it's important to remember that if you have a tuple which consists of only a single element, then you have to put the comma at the end of that element to be considered as a tuple. This was about two-dimensional list and tuples. Thank you so much for watching the video. If you do not have subscribed to the channel, please do subscribe. Thank you so much. Goodbye.